We're going to do a quick little recap to help us all get in the, at least mindset, if not the mood, because the mood seems like death in here. Try to get a little bit more lively, hopefully. Right, Caden? Right. And then we're going to get into the textbook pages that we tore out. So, I was going to do Hero Friday, but Makari is not feeling it. Is there anybody who wants to go instead?
I said make Mr. Hopkins. Yeah, I'm saying let him go.
Have you not gone in yet?
I have not gone yet.
Did you just do it in first block?
I haven't. Hero Friday, I haven't done it ever, actually.
I could have sworn I had you do it. That's my bad. I thought I had.
I can do it next Friday for first block, yeah. Yeah.
Yeah, you can do it next Friday, first and third, because I won't be here.
Yeah.
So we're gonna meet you.
Yeah, you'll hear mine next Friday.
So we're
I'm glad I won't see you too.
I'm not in
Big
here.
Big jam then.
To be fair, I'm gonna be having tons of fun. So,
Sure.
because I'm gonna be learning. I'm going to Chicago for a conference. I am leading
I'm not doing no work.
2 different sessions at the conference, but then I'll be going to lots of sessions about new resources to teach better, talking with a whole bunch of other math teachers, things like that, to just learn how to be.
We're gonna be a big jam.
Happily to go to the rest of my.
You must be outside your mind if you think I'm letting y'all go to the
Still
gym.
gonna be there though, just let me know.
I already have a sub. Mr. Javi will also be here on Monday or on Wednesday and on Friday.
So you won't be on Wednesday.
He'll be here Wednesday, Thursday, or Friday.
Okay.
But Mr. Javi will be here Wednesday and Friday, and also y'all have a test on Wednesday.
On this right here?
This
Wednesday?
Wednesday?
I
I
mean,
mean,
And then you have
next
exponential and quadratic.
Next Wednesday?
Yes.
I thought you just said you were a weekend next Wednesday.
Why do you need me here to take a test?
Yeah.
Oh yeah, you right.
I will be putting y'all in rows, and y'all will be taking your test. There will be a calculator portion and a non-calculator portion.
That's okay.
How
Yeah.
many questions?
Can I go to the bathroom?
Nope. She's not me.
Who is
Don't worry about it. You'll find out.
Can I go to
You'll
the
find
bathroom?
out.
No, because some shows I don't be liking them.
I'm sorry.
So you can just like send me to a leaflet later.
No, I can't do that. All right. So we're going to be connecting values in quadratic equations to features of the parabolas. We're going to even extend that into not so easy features. So we're going to recap which features we can easily see in those equations. By the way, what recommendation have I made that you have got to do that unfortunately most of us have not quite done yet?
The restroom.
Huh? No, what did you say? Say it. Oh no. What was it?
What was the question?
Okay, if you're going to be successful with these features of parabolas based on the quadratic equations, what do you have to do?
You got it.
Write down your equation.
You got to know your equations.
You had it right.
I know, Addison. Okay, listen, you got to write out those equations. You got to know, like, when I say standard form, you got to know f of x equals ax squared plus bx plus c. When I say vertex form, you got to know f of x equals a times x minus h squared plus k. Okay? We got to know those forms so that we can apply them and know what those different values mean. Apparently, I didn't put a picture in here for Hero Friday because I didn't have a picture. And then you're going to go next Friday.
Oh, next Friday.
Okay? Anyone want to go today? Going once? Going twice?
Sold. Nobody.
Sold. Alright, so I'll do a Hero Friday that I always have on backup. I don't have a picture of him because I didn't pull up a picture because I didn't know I was going to be going right now. But in high school, my cross-country coach and my speech and debate teacher, so everybody at my high school freshman year, had to take a research, speech, and debate class. And he is, hands down, the one person that influenced me the most. I know I'm a math teacher, so you think it's a math teacher, but no, Coach Colvin, Chris Colvin was his name, is his name. He's still alive. He's still teaching and coaching in Montgomery, where I grew up. He pushed me to be more. With cross country, one of the things, and he was my cross country coach. I actually played for him soccer one year when we didn't have a track team. One of the things that he challenged me on and encouraged me to do with cross country was to learn to push through the pain. I know it's going to sound weird, and it's one of those things that has helped me be the academic that I am today. School, it's not always fun, is it? It's not. It's not, especially if we've struggled with it.
Yeah.
Running, is it always fun?
Yes.
Probably not for most of us, but for some of us it is. It is painful. And what we learned in cross country, what we learned with Coach Colvin was how to push through the pain and to embrace the pain to be better. And that's one of those things that has encouraged and challenged me and helped me be the man I am today. But on top of that, he was also someone who always cared and always was there for me. I actually got a chance to go back and teach at Lamp, my high school, for 1 year, and I coached with him. And he is someone that I knew I could always find encouragement from, and he would just challenge me to be a better person. And so a lot of times when you look at me and I don't answer questions completely and I ask you questions in response, it's because of him. It's also because of a professor I have at UA named Dr. Zelkowski. But it was through his teaching that I saw him ask me questions that forced me to think, that made me become the person I am today. Thinking's hard. It's not easy. It's painful, just like cross country was. But it was when I learned to think that I became the best version of myself. That's how it is for everybody. When you learn to think and overcome the struggle, that's when you're going to be the best version of yourself. And so I'm thankful for Coach Colvin every day, and that he was a huge influence in my life. So, looking at today though, looking at our different forms, x-intercepts, y-intercepts, we've covered the different forms. I'm going to rewrite some details up here in a second. But today, the priority is going to be graphing quadratic functions by hand using the key features identified in that specific form. So each form has a different feature. We need to remember that. We're going to do a quick recap of that in a second, which is why I don't want to write it right now. But what we're going to extend that into is being able to identify all key features of quadratic function. So, what are the 5 features of a parabola that we are always thinking about? Line of symmetry, there's one. Concavity. What can the minimum connect to? The vertex. Remember, it could be a minimum or a maximum depending on the concavity. But that's the vertex, right? So we've got line of symmetry, we've got concavity, we've got vertex, we've got y-intercept, and what do the roots connect to? The x-intercepts are zeros, right? So we've got those 5 features. We got those 5 features, and so what we're learning today is making sure, 1, we know how to identify each of those, and 2, that we can connect that. So this is the Desmos activity. For the sake of time, don't pull out your iPads today. What we're going to do is we're going to start here. Yeah. Who is it? Where you been? Thank you. For now, just grab a seat at the Queen section. I'll let you work with the keys today, okay? Because we're missing 2 of them. All right. So when I look at this here, and so we're going to have jacks, 10s, and 4s up here. Oh, that would make sense, wouldn't it? Come on with it. Well, wait till we start working in a second, then y'all can move over here. So, key features of these parabolas. So, vertex form. What was the equation for vertex form?
35.
AX squared plus BX plus C.
That is one of them, but that is not vertex form. Vertex.
The A, H minus K squared.
What was after the A?
A, after the A is the H. First of all, the parentheses H minus K squared plus K.
Alright, is that right?
No, it's supposed to be x minus h.
So remember, well, we'll talk about it more, but x minus h squared. So it's a good start, valiant effort, but x minus h squared. Again, practice it. Note cards, Quizlet, writing it out, whatever you got to do, make sure you know this equation. What's our standard form?
AX squared plus BX plus C.
Okay. And then what's our factored form?
A. What was that? Something minus R.
Parentheses. It doesn't start with R1.
X. x minus r1, and then another parenthesis, x minus r2.
There we go. So what I want us to do as a quick recap, I want y'all to take, let's say 5 minutes, hopefully no more than that. I want you to identify which key features of a parabola are highlighted in the different forms. Every parabola has roots, every parabola has y-intercepts, every parabola has some kind of concavity, but I'm asking which ones are highlighted. When I see vertex form, should I be able to see the concavity right away?
No. Yeah.
What tells me the concavity every time?
A.
A. So, I'm going to put a check mark, and I'm going to put a note of A here. Alright? If you can see the vertex, put a check mark there, and just make a note of what tells you the vertex. Does that make sense? Actually, to speed this up, let's do this. Aces, y'all are going to have vertex form. Kings, y'all are going to have standard. Queens, factored form. Jacks, vertex form. Tens, standard form. Y'all nines, factored form. Eights, vertex form. And fours, y'all are going to have standard form. Does that make sense? So y'all are just going to focus on that equation and identify which features you can easily see and what they are. Like, so what tells me what the vertex is? What tells me what the x-intercepts are? So you just have to focus on how many equations? One, just the one that I assigned you. Everyone knows which ones they have? Alright, let's get up to our vertical surfaces. Let's identify what those key features are. Remember, here are the equations, but also you should have your notes. You should have your notes. Remember, I want you walking into the center so that you're more engaged in the conversation. You hide in the back, hide on the walls. It's easier to disengage. I need you talking, asking questions. Remember, it's okay to not know. It is not okay to stay not knowing. Let me say that again. It is okay to not know. It is not okay to stay not knowing. If something doesn't make sense, ask that question. Now, we're going to start with this vertex form. Guys, one of my favorite things about the vertex form is the name tells you what you need to know.
I'll come up here.
What do we know from vertex form? You got to know that vertex, right? So when I look at this vertex form, what is telling me my vertex that we have written around the room? H and K. And I want to emphasize, I want y'all to look at group 8 over here, or the 8s. What did they do a great job of, and we see it up here as well, writing that vertex form. They wrote it as a what? Point. It's not just x and y, right? Whatever the h is, that is the x value of the point, right? Whatever the k is, that's the y value. Now, one thing I want you to be careful about is, when we're doing h and k, just like all of these values, we always do a lowercase. So lowercase h, lowercase k. We'll go with that?
Yes, sir.
Now, most of us didn't write this, but I need y'all to be careful about this. I actually do see it in one other group. One of the most common mistakes students make with vertex form is they try to tell me that h is the x-intercept. They write h comma 0. However, I want to point out two things. Usually, how many x-intercepts are there?
One.
Two,
yeah.
There's usually 2 x-intercepts. I won't say always.
Yeah.
There will always be 2 roots. We'll actually explore that heavily next unit. But there's usually 2 x-intercepts, okay? So h comma 0, that's only 1. But also, note what I made a note of up here. Because they originally had h0 and they had 0k. But what feature does vertex form show us?
The x value of the vertex.
The vertex. What does vertex form tell us? The
Value.
vertex, okay? It tells us the
Vertex.
vertex, okay. So, the vertex form tells us vertex. That's the x value, and that's what people focus on, but it's the x value of the vertex. It's the y value of the vertex. Not x-intercepts, not y-intercepts. So are we talking about x-intercepts and y-intercepts in vertex form?
No.
Don't do it. Take it out. Now, do we talk about a line of symmetry in the vertex form?
Yes.
Yeah. Remember, when I draw a graph, if I have a parabola that looks like this, What point does my line of symmetry have to go through? Well, that's a value. What point does it have to go through? The vertex, right? Here's my vertex, h comma k. That line of symmetry has to go right through it. And so that's a full line of x equal h. Whatever h is, that's what your x value will be every time, right? We looked at that yesterday. Whatever h was, that was the x value of every point on that line. So once again, here, notice, and I kind of like this notation, h comma question mark, because every point here, this could be h comma 1, h comma 5, h comma negative 1. Notice, I mean, it could be negative 2. Notice it doesn't matter what the y is. What is the x value every time? H. So on that vertical line, that line of symmetry, it doesn't matter what y is. X is always equal to h. Thank you. Woo. Standard form, looking around the room. So standard here. Standard here. What's telling us the concavity? A. All right. So, yes, we can see concavity. That's A. Vertex. Do we see that in standard form? Do we see it?
No.
No? Okay, so I'm going to leave that blank. Do we see the x-intercepts in standard form?
No.
Be careful. Do we see x or do we see y? Remember, we see y. What is the y-intercept? C. Now be careful. I want y'all to look at these different notes here. One of these is more accurate than the other. Which one?
The left one.
The first.
So left or right?
Left.
Left. Because the intercepts are always a what? Point. So if I say y-intercept, like I can say c equals a number, but if I'm talking about my y-intercept, it's the point 0 comma c. Do not forget, every y-intercept, or what is true of every y-intercept? The x is 0. We have a y, the x is 0. We have a y, the x is 0. All right, line of symmetry. Do we see that?
No.
Remember, I'll point this out. So this should, hopefully this helped y'all. Notice, vertex is h and k, right? Line of symmetry is x equals h. Do you see an h and a k here?
No.
So do we see our vertex and our line of symmetry here? No. Okay. So factored form, what shows me concavity? A. That A is the only thing that is in all three forms. So what's the only feature that you can always see in all three forms right away?
A.
Concavity. So can I see the vertex?
No.
Do I have an H and a K?
No.
No. Okay. So I'm leaving that blank. X-intercepts.
Yes.
What's showing me my x-intercepts?
R1 and R2.
X minus R1 and X minus R2. Now, I'm going to go ahead and show you the one thing I saw over here that I need to be very careful about because students ignore me on this or they forget this every time. I almost see it over there as well. I see students write it like this so many times, but these are x-intercepts, right?
Yep.
How many x-intercepts should I probably have? I should probably have 2. On top of that, is this an x value right here?
No, that's why.
That's y. With a y-intercept, the input was always 0.
Right.
With an x-intercept, the
Y is always 0.
y, or the output, is always 0. Make sure, if you're talking about your roots, the input is the root, the output is the 0. Now, Addison started freaking herself out earlier, right? She was like, but Mr. Kenny, I don't have the notes. Y'all, stay calm, because she did. Don't forget, why do we use R1 and R2? What does that stand for?
The X.
The-
Roots.
Why do we use R? Because it stands for roots. And as soon, I'm sorry, I didn't hear you. I only got 2 ears. My bad. But as soon as you said roots, you were like, oh, those are my x-intercepts, right? So remember, we don't use letters at random. R1 and R2 are for roots, okay? And so that's for my x-intercepts. So y-intercept, do I immediately see it?
Yeah.
No. Line of symmetry, do I immediately see it? No. So I want you to note, every form has concavity, right, in that A. Other than that, every form has its own feature. Vertex form has The vertex. And the
Line of
line of symmetry. The standard form has the
Y-intercept.
y-intercept, and the factored form has the
X-intercept.
x-intercepts. You see how they each have their own feature? So you should not ever tell me right away, oh, I see vertex and I see x-intercepts. No, if it's vertex form, I see the vertex. And use the name of the form to help you remember it. Use the letters to help you remember what these things are. Now, one thing I want to caution, I want to push back on, just language-wise, be careful. Group of nines over there. They said there is no vertex and no y-intercept. If it's a parabola, is there a vertex?
Yes.
Yes. Is it immediately visible though?
No.
No. So be careful on that. If there's a parabola, there is concavity, there is a vertex. On the x-intercepts, I'll explain y next unit, but there's always roots, there's always a y-intercept, and there's always a line of symmetry. Okay? So, it's there. The question is, how do we find it? And we're going to talk about it more in just a second, but what I want to encourage you to do is grab a seat, do some notes to your future forgetful self a little bit, update your knowledge. Okay? You have a section for standard form, you have a section for factored form, you have a section for vertex form. Add a little bit more detail in there if you need to. It's a great time for you to ask Mr. Hobby a question, ask myself a question, improve your understanding. Can I simplify that equation for that expression and get what the output is? Notice this 0 is telling me that 0 is what? Starts with an I. It's x, but it's also called my, starts with an I.
Intercept.
What did you say?
Input.
Inputs, right? A function is a mapping of inputs to outputs, or at least that's what a relation is. Function is that special case. So f of 0 equals, what's 0 minus 1?
1.
Close. Negative 1, and what's negative 1 squared? Negative 1 times negative 1 is?
Negative 1.
I say, what's a negative times a negative?
Oh, yeah.
Positive. So positive 1 plus 4. So in this case, my y-intercept is 0, comma 6.
So that would be.
So if I want my y-intercept, what do I need to do? Substitute 0 in for x. If you understand that a y-intercept has an input of 0, that's all you got to do. Substitute 0 in for x. Any guesses what I would do in this factor? So make sure in a second when you get a chance, you're going to write this note in for which form?
Vertex.
Vertex form, right? That's the form we're looking at. But here, any guesses what I'm going to do to find my y-intercept in this factored form? Hey guys, pause for a second. I'll give you a chance to write those notes in a second. I want to make sure that we're driving this point home. Now I have a factored form. The y-intercept is not immediately visible, but what can I do to find that y-intercept? Substitute 0 in for x, right? If I want a y-intercept, all I got to do is substitute 0 in for x. See, that bell's about to catch us, but when you come back, I need you to make notes about this. Well, wait till that bell actually catches us. So, 0, comma 4 would be my y-intercept. Notice the y-intercept is always easy. What do you have to do to find that y-intercept? Substitute 0 in for x. When we get so, hey guys, focus. So, when we left off, remember, we have a different feature that every equation easily reveals. However, we talked about the y-intercept. Okay? How can we always find that y-intercept? Let x equal what? 0, right? Remember, if I'm looking at a y-intercept, what is that x value always? 0. So substitute that 0 in, and whatever your output is, remember, input and output. So if your input 0, your output is the y-intercept, okay? But we now need to look at vertex and line of symmetry. So first things first, And I'm just going to do this as a whole class, save us a little bit of time because we got to get going. We're now going to just try to find out, which form am I looking at, by the way?
Standard.
No.
It says ax squared plus bx plus c is standard form, okay? So we got standard form. Yo, chill.
Not that.
Okay. Can you actually hit the lights for me, Maya, so that we can see this easier? It's right there's standard form. And so I just want us to try to figure out what of those values is affecting the line of symmetry. What is affecting the vertex? No, I haven't even moved a single thing yet. So, as I change A, is A changing the line of symmetry in the vertex?
Put my pencil back.
Yeah.
Yes.
Okay,
Yes.
so does A affect those both?
Yes.
Yes, okay. What about B? Does B affect the or the vertex and the line of symmetry?
Yes.
Yes. Remember when we were like, oh, we haven't looked at B yet, and I told you B on its own, excuse me, B on its own is not anything, but A and B together affect what?
The line of symmetry.
The line of symmetry, the Y or the vertex, right? Okay, so the B and the A together affect the line of symmetry. Can someone let Jamie in, please? Now C, does C change that the line of symmetry? Anybody? Is C changing the line of symmetry?
No.
It's changing the vertex, but is it changing the x value of the vertex?
No.
No, okay. So, do we care about C if we're trying to look at the line of symmetry in the vertex?
No.
No. Okay, so I'm going to make our life a little bit easier. I'm going to go with a 4 there. Nope, go back. Okay. And let's say negative 1. Let's go negative 2. All right. So now, let's look at these values that are up here. What would be the equation for this quadratic? F of x equals what? Negative 2. Comes out to that negative 2.
4. Parentheses.
You guys.
The x.
Not just x.
X squared.
Thank you. Negative 2x squared
That's what I ain't drawing out.
plus 4x
Plus 3.
plus 3. Okay. So there's my standard form for this equation. Now, does anyone see anything on this page that is defining what the h value is? Or actually, let's say it this way. I should have started here. What letter do we use to represent the x value of the vertex?
The A.
Say again? Remember h. Remember, the vertex is not in the standard form right away, but how do we find the h value? Or what we're trying to find out is how to find that h value. The h is the x value of my vertex. Does anyone see anything on here that relates A and B and might be defining the x value of the vertex?
That green line.
Yep. Okay, so that green line goes through it, but look at the calculations on this page. The x value of the vertex, what is it right now? The x value of the vertex is 1. Look at the calculations on this page. Does anyone see anything anywhere that has a value of 1?
No.
Look again.
Yeah.
Where?
Right there.
4.
Can you come point at it? Come on up here, Taj.
Oh, you talking about the? Oh,
Little thing at the bottom first.
Little thing at the bottom.
coming at B right now?
Drum roll.
Oh. This negative b divided by 2a. That gave me a 1, didn't it?
Yeah.
Okay. Let's see if I change things again, if that still happens. Alright, so let's go to, I'm going to go all the way to negative 8. Ooh, it's pretty far away. Can't actually see it right now. Alright, so what is the x value of my vertex now?
Negative 2.
Negative 2. Is that negative b divided by 2a giving me negative 2 again?
Yes.
Okay, so
You saying?
is the negative b divided by 2a giving me that negative 2 again?
Yeah.
So how do we calculate h from standard form?
We use the
Divided by 2A.
A.
Divided by 2a. Okay? There's, as far as I'm aware, until next unit, there's not a full reason I can explain it to you, so I can't tell you why. Or until you take a calculus class, I can't fully explain why. But we can empirically see by changing our data, by changing these values, that negative b divided by 2a, isn't that defining what h is? Which makes sense because then we just say what affects the vertex, the a and the b. The way that we define h is the opposite of b, that's the way you'll usually hear me say it, divided by 2a. So, let's say I change it to negative 1x squared plus 4x plus 3. How would I find h in that case?
You have to use h equals negative b, and the bottom number is negative 1.
Okay, so negative b, what's that going to become?
Negative 1.
4.
Is it 4 or negative 4?
Negative 4.
Notice it is the opposite, right?
Or it'd be
So if b is 4, what's the opposite of 4?
Negative 4.
Negative 4, divided by?
negative 1.
2a. So it should be 2.
So remember what's happening between the 2 and the a, they're being,
Divide.
so 2 times negative 1,
Negative
so negative 4 divided by negative 2, which is?
Negative 2.
We got calculators all throughout this room. If we haven't grabbed one, we might want one. But negative 4 divided by negative 2 is? 2. Okay? So first things first, I want to point out, have we found the axis of symmetry? Or could we know what the axis of symmetry is at this point?
Yes.
How did we write the axis of symmetry earlier? So I see it's still over there a little bit. Someone accidentally erased it, but where talking through was working. How did we write the axis of symmetry?
Yeah, just walk right there.
Because there was an equation we had to write for axis of symmetry.
You should mean by axis.
Line of symmetry is the axis of symmetry. How do we write the line of symmetry? H equals x or x equals h. So if x is equal to h, what is h in this case?
Whatever x is, not 2.
X is equal to 2. Okay? So the line of symmetry for this one should be x equals 2. We're going to check that in a second. Now, last detail for this one. I've got the h. What do I still need for the vertex? Still need the k, right?
Yeah.
I thought this was standard. We didn't worry about that.
I mean, we weren't worried about h with standard form originally either, but we're now trying to find it.
You didn't use complex?
Huh? Just hold on. Any ideas how I can find k?
No.
Okay, so let me remind you of
Maybe
something.
Wouldn't it be
negative
the
first.
same thing?
Would it be negative first?
So let me remind you. That's my vertex, correct? What's another word for this x value? It's not the x-intercept. It is an x value, but there's an I word that we use for it.
Input.
Oh, it's the input. So what is k?
Output.
So if I have the input, how am I going to find the k? I'm going to what? Okay, so how am I going to do that though? So let me, well, we don't have it on the board right now. Let me point out this way. If h is my input, what's going to be my output? If h is my input, what's the output? Okay. So, let's say I substitute that 2 in. Whatever I get out when I substitute 2 in, that's going to be what? It's the output. Which output? The k. There's my input of h. My output's going to be k. So let's check it. So, where was it? Negative 1. What's taking the place of x? 2 squared plus 4. What's taking the place of x? Times 2 plus 3. Alright, so you can just type all this into the calculator if you want. So that would be negative 4 plus 8 plus 3 or 7. So my vertex should be 2 comma what? My input was 2, my output was?
6.
Let's check. Alright, so A was what again?
Negative.
Negative 1, I thought, right?
Oh, yeah.
Negative 1, and then my B was
4.
positive 4. C was 3. Is my vertex 2 comma 7? Sure enough. Now, Bakari asked the question, hey, are you going to have problems like this? So, 1, if I give you standard form, could you find the line of symmetry and the vertex?
Yes.
Yeah.
Maybe.
I mean, did we just do it?
Yeah.
So, could you do it?
Yes.
Yes. Now, is the vertex or the line of symmetry something that's immediately obvious in that standard form? Or did we have to do work to get there?
You have to work.
We have to do work to get there. If you have to do work to get there, it is not something that is required. It is good and it is helpful. It is how you get to the exceeds portion on the proficiency scale. However, hear me very clearly on this. This is something you're going to have to master next unit. Okay? So if you want to get a jump start on your learning for next unit, go ahead and start learning how to find the vertex from standard form. Okay? So, on your standard form set of notes, I would like you to add in this information about how to find what? The vertex, right? So, how to find, what are we trying to find? Well, but what's the first part of that? H. And the vertex from which form? So it's how to find H and the vertex from standard form. I would put this under the standard form section, right? So remember, and this is the basic premise. Remember on the y-intercept, the input was 0, so we just substituted that in for x? My input is what? So if I know what h is, I substitute h in, and what's going to naturally come out? Okay. So what did I do? I substituted my h of 2 in, and when I simplified it, what came out? And that's my k. So remember, that's why I keep using that language of inputs and outputs. If I recognize that h is my input, that means k has to be the output. So you substitute h in, get k out. And so like, that's work for it, but that's a good thing to write. So to get vertex, first you got to find h. We have that formula to find h. But how are we going to find the vertex after we get h? Substitute what? H in, and what happens? And k comes out. Inputs and outputs. Substitute h in, and k is going to come out.
That 2 times m on the b thing
Divided by 2a. Remember, we just looked at it right
I can
here.
look at 2 diagrams.
Go. 2a. 2 times a.
That's so.
Nope. I'm going to hurt your eyeballs.
I ain't even know. I feel like see it hurt my eyeballs.
Dude.
You just be joking though. You really not. Thanks. You're like joking. You be good. Try to make it fun, you know. What you be saying sometimes don't make no sense, right?
Huh?
That's how what you be saying should make no sense. Again on that.
What? Yes, I do. Okay. So,
Miss, can I got a question?
go for it.
Oh, yeah, we'll take that.
Is that the word right?
Is that one time?
Is that mine? That's the word right?
It's mine. Is that mine? M-I-N-E. Is that mine?
just come up.
Getting paid once a month is the same as getting paid 4 times a month. It's just, you get all covered. You don't make less, you just get more at a time.
He threw it in my face.
If you get paid $800 every week, or you get paid $3,200 at the end of the month, which one's making more? At the vertex from that standard form, now we need to look at the line of symmetry and the vertex from which form? From factored form, right? Now, is line of symmetry and vertex something that you're going to have to know for the test?
Huh? You read that again?
Are you going to have to know line of symmetry and vertex from factored form for the test?
Yes.
Please. Oh, thank God.
I got one question.
Remember,
Just be
hold on
honest.
1 second, Tasha. Hold on. Remember, on the test, what you have to know is what's immediately visible. We need to know concavity and x-intercepts from factored form. It is good to remember how to find those other features, but it's going to also be helpful in a second. Taj, what were you asking?
How do we get symmetrical on the first one?
How do we find the line of symmetry?
Yeah, line of symmetry.
Well, remember, the line of symmetry is just
Oh,
x equals h. So once you have h, you have the line of symmetry. Good question. But remember, the line of symmetry is x equals h. So once you have h, you've got your line of symmetry. All right. I want y'all to pay attention. What's the line of symmetry in the graph right now? How do we know where it is? The green line is my line of symmetry. -1, -4 is only the vertex. So, what is affecting that line of symmetry?
A, like you control it.
I mean, is A changing the line of symmetry though?
No.
No?
It just
It stays.
What about the root?
Yes.
Yes, the root definitely is, isn't it?
We should put that in our notes, right? The root change the
Well,
line.
we need to know how it's changing it. So, I want you to make a prediction. How is that line of symmetry, note it's going to be x equals -1, how is that line of symmetry related to the two roots here? How is that line of symmetry related to the two roots? Okay, so they're symmetrical from each other, right?
Yeah.
No, so they're the same distance from either side, so we can say the line of symmetry is where? It's in the middle. Now I want y'all to pause, I want you to think, right? But remember, think, communicate, collaborate, that's how we're successful. Think, if I were to give you the numbers 7, 17, 24, 33, how would you find the middle of those four numbers?
Symmetrical to each other.
So, we have 4 numbers, 7, 17, 24, 33. How would I find the middle of those? Add them up, divide by 4. So add all the numbers we have together, divide by how many numbers we had, right? What's that called? We would average them, right? Hey guys, how are we going to find our axis of symmetry when we have roots? Can I average these roots and find the middle? Yeah, what's 1 plus -3? -2. What's -2 divided by 2? Oh. So to find my h from factored form, what do I have to do to find h from factored form? Average the roots. So, to find h, and so this might be good to put on my factored form sheet, to find h from factored form, average the roots. It's quite literally in the middle. And so if you want a formula, here's the formula. I would just remember to average the roots, but literally I'm adding these two numbers together and dividing by 2 because I've added two numbers together. I've just found the average of my roots. So what am I going to do with this factored form to find h. You agree? 2 plus negative 4? Divided by 2? Huh?
Two is right.
Hey, Victoria, I always give you time afterwards to write.
No, I'm
Engage in this learning right now.
Minus negative.
What's right?
It's what?
Look at 2 minus 4.
It's what? I don't think so.
Ooh, the opposite.
What is it?
Opposite.
Remember, I need the opposite, don't I? It's x minus r1. So to get x plus 2, I needed a
Negative.
negative 2. Remember, if you substitute 2 in, what's 2 plus 2?
4.
Is it that 0 that I want?
No.
No. I needed a negative 2. What's r2?
4.
4. So if I want h, I'm going to average negative 2 and 4. There's an example of finding that h. And so now I know my line of symmetry. X equals 1, right? X is equal to h. How am I going to find k? I'm not vertex. Okay, has that changed?
No.
No, if I know what h is, that's my input, my output's going to be k. Right? So if I want k, that's just going to be the output for h. F of h is equal to k. So f of 1 equals negative 1 times 1 plus 2 times 1 minus 4. And what's 1 plus 2?
3.
3. What's 1 minus 4?
3.
Negative 3.
And so what is f of 1 equal to? What's negative 1 times 3?
Negative 3.
What's negative 3 times negative 3?
3. I mean 1. Negative 3 times negative 3. Oh, 9.
What's 3 times 3?
9.
9. And a negative times a negative is a positive. So f of 1 is equal to 9.
Something.
Now, so we now have strategies to fill in the rest of this. If I want everything except x-intercepts. X-intercepts are actually harder to find in vertex and standard form. That's actually what next unit is going to be all about. So we're going to continue working with quadratics next unit to learn how to find the x-intercepts or the zeros from standard or vertex and standard form. But if I want a y-intercept, what do we know about every y-intercept that has and will ever exist?
X is going to be 0.
That x is going to be 0, right? Okay? And that's always going to be the case. For the vertex, I got to find h. Once I have h, that's going to become my what?
Input.
Don't forget, h is going to become that input.
Yeah. K be the output, right?
Okay? So, remember, for our test, if I give you a factored form, on this one, all I need you to recognize is I have x-intercepts at negative 2, 0, and 4, 0. This parabola is going to be concave down. However, I now also, this is the extra that can get us to the exceed. 1, 9 is my vertex. X equals 1 is my line of symmetry. What is the last thing that you can find in order to get every key feature for this parabola? I already have K. I got the vertex, 1, 9. What else do I still need? Say it louder.
Oh, you said you already got it.
Say again. Say it louder. Well, yeah, but there's another point I can find to help me get that parabola.
Y is 0.
Thank you. I've got x-intercepts, I got line of symmetry, I've got vertex, I've got concavity. I just need the y-intercept. How am I going to find that y-intercept?
Where
Y-intercepts, what do we know?
The X.
The input, the x, is going to be 0.
We ain't gotta do none of that, we'll have to do all that work.
You do not have to do the y-intercept, you do not have to do the line of symmetry, you do not have to do the vertex from factored form, but that's how you get to the exceeds, and it's going to help you in the next unit. But if you learn it now, you know it's going to make next unit a lot easier. That's why I'm always planning and teaching for the future, not just for the right now. It all connects and it all builds. So I found every feature.
Next question.
I can do the same thing with this standard form. I now have the vertex. What was that vertex? 2, 7?
Yeah.
2, 7. And I know the y-intercept already was 0, 3. Don't forget there's a line of symmetry here. So I know that there's also this point. That gives me a much better parabola.
Why don't you just put it on the little line?
What are you talking about?
The line.
What line are you talking
You
about?
talking about that down through that's like up from that's up there? Or you just put it on the line like
The y-axis?
The line of the projector. Just the line.
Oh, I don't know.
you know what I'm talking
I do now. I just wasn't slicing.
about? No, I'm saying.
That's not relevant to that.
It's not. That doesn't matter. Okay.
Either way it'll work, right?
Okay.
Okay.
All right. What are your questions about finding your vertex from factored and standard formula? I know some of us are already taking notes. Please take a couple minutes to update any final notes you need for that factored and standard form. Once again, knowing how to find that vertex is going to be very, very, very helpful for you next unit. So I would go ahead and start practicing that. Huh?
That's why it's so much on the board, like, what?
Cameron, this is the last thing that is on the target portion of your proficiency scale. Does anyone remember or have their proficiency scale out to be able to know the last thing on there that we have to know for targets?
I grab all of them, all foundation, no, you guys, what's the last part of the target, on the proficiency?
Look, so at this point, we should be able to identify each form of a quadratic, yeah? Hopefully. Quadratic function, standard form, vertex form, factored form of quadratic equations, x-intercepts, y-intercepts, all foundation. Graphing quadratics by hand using the key features. Literally, if you know what a y-intercept is and you graph that y-intercept and then use your concavity to get a sketch, you're good, right? So the key features identified in that specific form. What about this last one? Have we talked about converting from factored form to standard form? Not yet. And so we got to speed things along a little bit. So I would have out my factored form notes page, and I would if you don't have space on the front, I would go to the other side, or at least somewhere, make some quick notes. This is not going to be terribly long, I promise. What have you done in previous math classes with factored expressions like this?
Like terms?
So eventually we do get to like terms. So there's a step before that because we don't have any like terms yet.
Oh, no, I've got the word.
Distribute.
We distributed, haven't we?
Yeah, sure.
We've distributed in these cases, and that is going to give us like terms, Kalia. Now, one thing I want to go ahead and show you is I use this. I know Ms. Williams has used this. I don't know about other math teachers, but there is something called an area model that helps us to distribute.
Sorry about
Okay. If you need to, then you can get another sheet out or something, but just right here, area model to distribute. This is a box, right? And by a box, I really mean a square. right? The area model, square. When you talk about the area, you're talking about the stuff that is where? On the inside, right? Okay. When we talk about area, we're talking about that stuff on the inside. And so what I'm going to do is I'm going to mark off the top, I'm going to mark off this left side, and I'm going to put my two factors in the marked off spaces. X plus 2 and x minus 4. Okay? X plus 2 and x minus 4. At this point, guess what I need to fill in? The rest of it. When you say the rest of it, I need to fill in the area. The area is that where? On the inside, right? So I'm going to mark this off so that I can see these different pieces. And I'm going to multiply. What is x times x?
2x.
Not 2x. Guys, how do I show repeated multiplication? An exponent. How many x's do I have? Alright, 2x's being multiplied. X squared. You need to be careful. Remember, 2x means x added, right? 2x means that x plus x. We have x times x, so we are multiplying. We need x squared. Now, what is x times 2? X times 2 is just 2x, right? That's what x times 2 is. What's negative 4 times x? Negative 4x. And what is negative 4 times 2? Negative 8. Now, we're adding all these terms. Remember, this isn't the only way to do it. Your previous teachers may have easily just shown you distribution this way. X times x is x squared. X times negative 4 is minus 4x. 2 times x is 2x. 2 times negative 4 is negative 8. And that's how I used to teach students. However, this area model is going to help us factor. And this area, like to go to factor form, this area model is going to help us when we're multiplying lots of things to stay organized. So I always use this area model to help me distribute. Now, what like terms do you see up here?
X.
So I see x's, don't I?
Yeah.
So I'm adding those two things.
Yes.
So I've got x squared. What's negative 4x plus 2x?
Negative 6x.
It's going to get less negative because we're adding. Negative 2x. Now you're going to have calculators, okay?
That would have been 6, right?
Minus 8. It was 2 negatives, yeah.
Right.
Now that is only this piece. What still is out in front of that multiplying? You notice that's in front of the whole thing. So now I have to distribute my negative 1. And so this expression would be this. So how do I get the standard form from the factored form? So if I have factored form, how am I going to get standard form? There's a keyword I need to hear.
Input.
I got to distribute. And how do I recommend that you distribute? Area model. Do you have to use area model? No, but I promise you, long term, if you learn to use that area model to help you distribute, you're going to be better off. Hey, listen. The first half of Monday, we're going to be practicing with these skills. But we will have a demonstrate your understanding in the second half. So if I were you over this weekend, I would do some check your understanding questions. And that way you can come in and ask questions. You can now do the mild, the medium, and the spicy from all the check your understandings. The spicy questions note is identify all possible features. Mr. Hobby, can you help me grab cards, please?
Absolutely.
Yeah, the spicy is not just finding the highlighted features, but finding all the features. Hey guys, also, I actually already uploaded a video for first block on all of those features. So I would highly recommend, if you're struggling, huh? Well, I literally just titled it, check your understanding questions for forms of quadratics or something like that. So it is titled that. If you need help, let me know. Thank you.
Can I have that card?
Thank you. Mr. Hobby, can you help me get these down first?
Absolutely.
Yeah. Definitely plan on getting to the book stuff. It didn't happen. It is what it is.